everybody.
Hello. 大家好，我这次演讲就应该会用英文讲，因为这个 presentation 我没就是以前没用中国讲过，所以就有问题的话呢，请举手问我一下。如果我讲得太快的话，也可以跟我讲一下。Hi, my name is Larry Salibra. I'm first to tell you a little bit about myself. I am the founder of New Internet Labs. New Internet Labs is a company that's building a new browser for apps that can't be evil. Previously, I was one of the original core developers at Blockstack. So first I was a community member in 2014 and joined the team full-time in 2016. And I helped to build the Blockstack browser, the Explorer, a lot of the developer tools. I'm also one of the co-founders of the Bitcoin Association of Hong Kong. So that was something we started about over 5 years ago. I want to talk a little bit about our agenda. So first we're going to talk a bit about problems with the current web. Then we're going to go on and talk about some principles of can't be evil apps, and what does that really mean. After that, we're going to give you a little bit of an introduction to Blockstack authentication and storage. And then we're going to walk through sort of a hands-on, for those of you that have your computers, building your first Blockstack app. First, I want to see a show of hands. Who here has heard of Blockstack before? Okay, not a lot of people. Who here is a developer? Which language? JavaScript, raise your hand. Something else. Something else. What do you? Kotlin. Oh, Kotlin's great. Yeah. Python. So we have some Python. We have some Kotlin developers. That's a pretty good crowd. Rust. I heard Rust.
Oh,
Go. Okay. So we have a good representation of a bunch of different languages here. So first, I want to talk a little bit about the current web. So this is what it looks like when you visit a website today. Like you type a name. Like here we're sort of looking at my accounting provider, EvilBooks. You go to EvilBooks, type in evilbooks.com, and you enter that assuming you're Alice, that you paid Bob $10,000. When you do that, all this information sort of like flies around to the cloud and goes to all these different servers, these boxes here at the bottom. So we've got servers like the server run by EvilBooks. You sort of assume that when you type some information into EvilBooks' website that it's going to go to their server. I think most users would assume that. But what you don't assume is that like that information potentially could go to a whole bunch of different other companies that you may not even have heard of. There's sort of the well-known ones like Google and Facebook. There's also some other ones like the JavaScript CDN that you linked your jQuery off of, or your React, or Unpackage. Or perhaps your font server, which also is often Google. So it's a pretty depressing situation if you're looking to sort of have any degree of privacy. I remember looking at my favorite. I'm interested in like sort of airline points. I looked at my favorite website, the Points Guy, before they did the revamp, and then loading the homepage made over 500 requests to something like 50 different hosts. So it's not very good for performance either. So that's sort of like where we are today. We can take a look I went at some popular websites. So this is my accounting software that I use. This is actually not QuickBooks. This is Wave Accounting, and you can see that it makes 137 requests for assets that are not hosted on their own server. And actually, 2 of them are to their competitor, which I thought was pretty interesting to Intuit. So that's also kind of depressing, and they want to think about switching accounting providers. If you look at the New York Times, which is sort of an ad-funded paper that everybody knows about, it's even worse. And one of the funny things is when I was sort of collecting these statistics a couple days ago, when I first visited QuickBooks to see how they were, and this is my own accounting software. And then I visited the New York Times, and this is what I saw. I saw this big ad for QuickBooks at the top of it. So QuickBooks, a company that is I'm supposed to trust my financial information to, has told the world's most famous newspaper that Larry has visited, probably used this software. They put it on the front page. Now maybe only I can see that, but that's information that any script potentially inside the page can know. Kind of made me feel uncomfortable. So sort of in the Blockstack project and ecosystem, we sort of like to think about apps in a way what we call can't be evil. So Google was very famous for saying, having in their sort of corporate policy, they should try not to be evil. They should don't be evil. Don't do things that could be evil. Our view is that you should never, as an app developer, put yourself in a position where you can do evil things to your customers. Sort of the way to put it is like you shouldn't be sitting there being like, hey, should we be evil or not? It shouldn't be a choice. We think that like we can sort of build technology and put together solutions that make it possible for app developers to make apps that can't be evil, and that it give customers sort of the ability to run some software that ensures that they can't be evil. So when we talk about can't be evil, what we're really talking about is trust minimization. And I sort of stole this terminology from Eric Szabo, who some of you may know, but he, like this concept of trust minimization, which is like how can we have the minimal amount of like trusted third parties or the minimal amount of trust to use the system. So sort of an example of what I like to think about is like when you go to the store and you buy a hammer, right? The hammer is made by a company, it's a product. Once you buy that hammer, you can do whatever you want with it. The hammer company doesn't know what you're doing with the hammer. Like the hammer company can't like turn off the ability to hit on nails. You don't have to trust the hammer company. Once you've bought the product, it's yours, and you just trust you have your own ability to use it. You're also, when you're hammering things with this hammer, you're not telling other companies that you're hammering things, right? It's just something you do sort of in the privacy of your own home. And so that's sort of like, I think, what a world of trust minimization looks like with apps. If we can sort of like take apps back to the time when they ran on our computers, we bought them in boxes from the store, and like once we bought the piece of software, no one really knew we were running it. They could provide updates to us and we could update it, but there wasn't sort of this like constant web that was tracking us. And trust minimization is ultimately why we decentralize. So we think about Ethereum. We could do everything that Ethereum does by running some software on one computer. But what we couldn't do is we couldn't do it in a trust minimized way. You could have built Ethereum on top of a MySQL database that Vitalik, who's outside, was running on his computer, and that would have been fine. But the reason Ethereum is interesting is because it tried to do sort of provide this sort of layer of infrastructure in a way that is trust minimized, where you're not having to trust the developers. They can't deplatform your app if you're building an app. So there's a whole bunch of benefits, which we don't need to talk about too much because most of you know, but immutability, censorship resistance, sort of this idea that you can use an app without being deplatformed, I think is very, very important. The ability to take your data and move it to different apps, I think is something that we really like to see and give the internet a lot of benefits. Also, as we know, the idea of owning your own money and controlling it is also very important. So what can we do when we're designing a can't be evil apps? So first thing is to design for the user first. Put yourself in the user's shoe and think, hey, like, how would I want this app to behave? Like, I wasn't thinking about like market conditions or like technical constraints. Like, if I was a user, what would I want to know? So let's apply that to something like Facebook. If you were building Facebook or Facebook Messenger, the user, when they're talking to their friends, they probably wouldn't want what they're saying to their girlfriend broadcast to the rest of the world. They'd probably be really unhappy to know that Facebook employees can access these messages pretty easily. Like just not even just one of them, any of them can, product managers, engineers. So that's something you think about when you're designing your product. You think, hey, what would the user want? What would they expect? They wouldn't expect that. They would hope that they can talk to their friends in a way that other people can't see and that no one else can prevent them from doing that. Try to figure out how you can design the app so that you're not sort of a trusted third party. You're not a single point of failure. So I think one of the bigger companies that tries to do this well, is Apple in some cases. They like to say like, hey, we don't want your data, and they're in a pretty good position to do that because they sell hardware devices. So I think that we can try to figure out a business model that lets us sell the software that we want people to run, but in a way that like we can't we're not between them and what they're trying to do. And another principle is sort of that users should only interact with the parties that they think they're interacting with. So when the users type in your website, they probably assume that like they're talking to like yourapp.com, which they don't know is they don't expect to be talking to all these other companies they've never heard of. I just saw a social media product launch today, and it's something, I'm not gonna say the name, but it's basically like a social, it's supposed to be a social sharing, or social events app for private social events apps. You can see what your friends are doing, where they are, what activity they're doing today. Maybe today they're going sailing, or maybe they're at a party. I went through and read the privacy terms of service, and it basically said that we collect all of your chats, we collect all of your locations, we collect all of your calendar, all these different things. Not only do we collect it, we store it, but not only do we store it, we give it to all of our vendors. And not only do we give it to all of our vendors, but we also give it to other people in semi-anonymous, anonymous, in a form where you can't be identified. I'm not going to try to say the word. So I think that's something that users wouldn't expect. So that's something you think about when you design these apps. And so what can you actually do? You can keep the business logic in the browser. So when we started the web, we had to make our business logic in servers, but now thanks to JavaScript and sort of single-page apps, we can do a lot of that business logic to browsers running on clients' computers as opposed to on our own servers. You should also store data in user storage, and users should only interact with the app origin. So if you need to send data back and forth to like servers, you can do that to your own origin, so like where you're serving the app from. And if you need to talk to a third party for whatever reason, for some back-end sort of processing computation, you can do that through your origin, right? That way you're at least responsible for the relationship between the user and the third parties, as opposed to like putting the user in a position where they have a relationship with a party they don't even know about. So some concrete steps are: make sure all your images, JavaScript, and fonts are on your server and not being linked off of other people's computers. Don't use cookies. Cookies send out tracking data whether or not you as a developer actually ask them to. If you need to remember a user, you can use something like local storage, and you can write some code to send a token back to your server when you need to do that. Redirects are sort of bad practice. Users type in a certain name, they click on a certain link, they don't expect to have their browser hijacked and redirected to 3 or 4 different single sign-in providers, sort of a bad practice. Again, client-side encrypt your user data. So if you don't need to use it, or perhaps the only other people who need to see some data are like your friends of your user, you can protect that data from your own eyes using client-side encryption. It's pretty easy these days. You can also store data in places that the users control. We'll talk about how to do that in a couple minutes. So now we're going to talk a little about Blockstack auth and storage. Since most of you don't know about Blockstack, I'm going to try to do a little bit of an introduction I wasn't planning to do. So Blockstack is sort of an app ecosystem for decentralized apps. And Blockstack takes a very different approach to decentralized apps than Ethereum does. Blockstack's view is that blockchains are really expensive and they're really slow. And so we should use blockchains as little as possible. We should try to keep most of the data and business logic off of blockchains if possible. And sort of like this makes them more scalable, and it also more closely aligns with users' expectations. Most users don't want to pay to tweet. It doesn't make any sense. They don't want to pay every time they click on a button. And even if they did, it would be very hard to scale these apps. We saw that with CryptoKitties. When everybody clicks on the button, the network gets really expensive and slow. So Blockstack originally started probably 2014, built a naming system on top of Namecoin, which is, Namecoin was one of the early forks of Bitcoin that was made for DNS. Learned a bunch of things from running on Namecoin, that why you actually want to be on the most secure blockchain for root of trust. Migrated to Bitcoin with some technology called virtual chain. At one point, we were about half of the non-financial transactions on Bitcoin, which actually isn't something to be proud of. It was because we were inefficiently using the space. We were making too many transactions for what we needed to do. as fees in Bitcoin started going up, we realized that it was very hard to have a good user experience on top of Bitcoin, but we still wanted the trust that we got from being the most secure chain. The last sort of year or so, there's been a new blockchain development using Rust. It's a proof of, I think it's called tunable proof of work, which is essentially a proof of burn blockchain. So you mine stacks blocks by burning Bitcoin, and you get stacks in exchange, which gives you a bunch of interesting characteristics. And it also has a small proof of work component. So Blockstack currently provides sort of some tools that make it really easy for developers to build the kind of apps that we like to think are sort of the right approach for decentralized apps. It provides Gaia, which is a storage hub for users. So it's a place where apps can store data on the user's behalf, and users can either use a public one or they can run their own. So that's really nice because app developers don't have to store data on behalf of the user in databases. It also provides a universal sort of sovereign identity system called Blockstack Auth, which lets you sign in to apps using public-private key cryptography, and you get a nice username that lets you interact with your friends on the network. So to sort of like, we sort of look at the cloud infrastructure as sort of like, we look at the way computing works as like this pendulum that swings back and forth. So like in the early days, it was mainframes, these really big computers that everybody like used together. You could like share it with your colleagues. And then sort of the pendulum swung back to the other side, the other extreme. We got personal computers, so everybody had a PC. And then we moved back to the other extreme now, where we have cloud computing, where our apps are essentially just sort of dumb terminals to someone's data center someplace. And we think that the world is moving back in the other direction. Computing is going to move back to devices, and client side. So we're looking at cloud. We look at the cloud computing. And we look at how can we sort of decentralize this. And to do that, we've gone through and created replacements for a lot of the popular tools that you use as a developer. So Facebook Connect, you can use something like Blockstack Auth to replace that, and different things like this. There's also sort of a bunch of apps that have come up in Blockstack universe that replace some of these popular apps that you may use on a daily basis. So I want to jump ahead here. So this is sort of the set of tools you get as a developer. The ones we're going to talk about today are file storage and authentication. Smart contract is running on testnet, but it is not launched on mainnet. That will come next year. We've learned a lot from Ethereum's sort of prior experience. Sort of designed our smart contract monitoring language to hopefully avoid some of the problems that happened, community arguments over bugs and stuff like that. So that's something to keep in mind in the future. Okay, so again, who has a computer here? We have like 8 people here. Okay, so we're going to start on the hands-on part of this talk. So if you can scan this QR code, or you can type in the address right here on the bottom of the screen. Those of you that have computers, it looks like everybody. How many people are not using a Mac? Any Windows computers here? 1, 2, Linux. Do you have a computer, or are you just raising your hand? Oh, your computer? Okay, awesome. Okay, so I'm going to be demoing this on Mac, but it should be very similar on Windows. And what you're going to need to have installed is like Git and then Node. Pretty much, those are the basic requirements. Anybody not have Git or Node installed? Okay, awesome. So hold on while I fill out our computer. Okay, so the first step, actually, let me, hold on a second. Okay, we're not gonna follow through this. We'll go through this tutorial on sort of like a word by word basis, but we're gonna roughly follow it. So the first thing First thing we're going to want to do is open it up and then click the Start button. And we're going to skip a lot about the learning of the platform since I've told you about that. The first thing we want to do is to create a Blockstack ID. That's something you're going to need to test your app. And you can do that by going to the address at the top of the screen. You can see it's browser.blockstack.org. And please, I guess, raise your hand when you get to this screen as you do computers. You can also do this on your phone too, if you want to try along, but you won't be able to do development on your phone. Who's got to the screen? Okay. We'll wait one more minute. Everybody okay? Yes? Okay. So what you want to do is you want to click on the Create Your New ID. I'm going to just create a throwaway ID here because I'm doing it on a projector. So you choose your name. Yeah, thanks. Let's choose CrossLink. So that's 19. So you choose the name you want. This is going to be your username. And you click Check Availability. You should do something different than mine. And choose a password. This password is going to be used to encrypt the secret that holds your identity. It'll be emailed to you in encrypted form. So if you lose your computer or you erase your browser, you can recover it by going to your email, following the instructions to recover, and using this password to decrypt the secret. I'm going to walk around and see how people are doing. Everybody created their Blockstack ID? Nice, nice, nice. Anybody having problems? Raise your hand. Problems? Okay, cool. You can continue. Okay, so once you create your Blockstack ID, you're gonna be sent to a home screen with a bunch of existing apps. You can check those out later after the talk. And I'll tell you, hopefully I'll remember at the end of the talk, about app mining, which is a program where if you're a developer, there's money each month for the top apps. So you could, if you create an app, you could submit it to app mining and then earn money every month. I think it was $200,000 this past month, but eventually it's going to be $1 million per month hand out to developers. So the apps that you see listed on this website are part of that program. Okay, so next up. The next step is to go, so if you go back to the tutorial that we opened up earlier, right here, let's see. If you go to, on the left side, it says try it, 0 to dApp. We're going to find a link that we can download some code. So if you go click try it, 0 to dApp, and then you scroll down to point number 2, learning about the platform, there is a line that says get the Animal Kingdom code. So what you want to do is you want to open the Animal Kingdom code repository. Let me see if I can show that to you on the screen. I guess I can't show it to you. Does everybody see that? The get animal code? Get Animal Kingdom code? you click start. Sorry about the delay. And then what we do is on the left side, we click try 0 to DAO. Number 2, learn about the platform. I haven't. I'm trying to show them on the web page. Okay, let's try another approach. How about this? Go to GitHub and go to this address. I thought I would save time using the link. It's github.com/blockstack/animal-kingdom. We're going to clone this. So I'm going to minimize my browser and then put a terminal up here. So first of all, clone the Animal Kingdom repo. Has everybody found it so far? Okay, I see terminal windows open, so that's positive. Awesome. One of the things you'll notice as you're cloning this app is that it's only one repo, and there's not really any server component. So it's a single page JavaScript app. I believe this is written with React, this demo. And the intention of the demo is not to be like an app that really does much of anything interesting, but to sort of show you some of the concepts that exist in Blockstack apps. So once you've cloned the app, you can run npm install and install all the dependencies. Oops. Anybody having problems? Any problems? Raise your hand. Help. Okay, let's install. That's still installing. Okay, everybody's trying to run npm install on the Wi-Fi at the same time, which of course isn't going to work well. Who has finished running npm install? Raise your hand. It's still running. Is it done? It's downloading. Okay. Well, let's wait a minute or two while it finishes downloading. Yes. You have to download the. You have to first clone it, and then you have to run npm install. I'm sorry? It's frozen. No. Did it work for you?
Yeah.
I think it has to compile something. And if you have your dependencies, it may work. Whoa, this is really cool. Did it work for you? It doesn't work.
Yeah.
Yeah, oh, you have to do command line? Yeah. I don't know. I think usually the same right here. So there's, if you go back to the tutorial, okay, we're going to continue now. If anyone else has problems. Okay, so once you've installed the dependencies, you can run the app. And we're going to run the app, and sort of going to walk you through the different parts of the app. You run the app by running npm space run space start. People have already loaded it. It's awesome. Yeah. So the stuff about can't be evil. This is sort of more of a direction. That's actually what my company is working on. So we're making a browser, and the goal of the browser will be that it sits between the user's apps, your apps you're running, and the rest of the world, and make sure the apps can't be evil. At the moment, what this particular demo shows us is how we can store data client-side end-to-end encrypted for users, and how we can store that data in the user's storage. What it doesn't show you is it doesn't show you how to like prevent third-party requests and sending data to other people. It just shows you one part of that, and so the other pieces are still under development. But these are two critical parts that you need for building can't be evil apps. Okay, so we've loaded this up, and you see this nice lion on the front page. I think his name's. I'm already signed in, so I'm going to sign out with another account. So you don't see a lion. You see this. You see the sign-in page, and open go. What we're going to do is we're going to click Sign In with Blockstack, and I'm going to walk you through what happens. So when you click Sign In with Blockstack, what happens is a JSON web token gets generated. And there's a nice JavaScript library we provide that does that. And in that library, a random ephemeral key gets generated. It's called the transit key. And what that's stored in the local storage of the instance of the app you're running. And what that's used for is for encrypting the data that's sent between the user's authenticator, in which this is the Blockstack browser, so it has the user's ID, and the app. So that makes sure that if the token that's sent between the app and the authenticator is ever lost, that the secrets in that can't be taken away. And so this token is created and has things like the app origin, the name of where the app is that's requesting authentication, and it also sends a list of the type of data and type of permissions that this app would like. So it can ask for the user's email, it can ask for the ability to publish data publicly that this app uses, and that's something you want to do if you want to interact with other people. So you can see in this instance that when I click on the sign-in button, the token, the authentication request token, which is here at the top of the screen, all these letters, is asking for the app that's running at localhost on port 3000 wants to read your basic info and also to publish data for this app. And so I'm going to click this as the user. I'm going to sign that token. I'm going to create a signed response using a private key that's derived specifically for this app from my identity. And I send that token back to the app. And then there's another function which is in our SDK, which reads that response, interprets it, cryptographically verifies it, makes sure, among other things, that the username that is sent back actually belongs to the person that signed the response. It gets information such as which nodes this particular user wants to interact with, where this particular user wants to store their data, things like that. So now we're signed in, and we can take a look at what actually happens when we click on some buttons. So I think the easiest way to do that is to sort of open the request inspector. I'm using Firefox because Chrome has problems on the projector. For some reason, it flashes in this virtual machine. But you can use whatever browser you want. So we're going to open up the inspector, look at the network requests. And we can see right now that it's generally just making requests to localhost. But if we go click on one of these buttons and we choose one of these animals to be our animal persona, let's say I'm going to be a cat with 9 lives. You see what happens. You see a request gets made to this hub.blockstack.org. This is the public storage hub that Blockstack Public Benefit Corporation runs for people to use for free. If you were to configure your own node, this would have your own host name in it as well too. What happens here is that a request is made to that user storage hub. If you look at the request URL here by clicking on it, you can see that it looks like there is a Bitcoin address in the request. That's not actually, I mean, it is in the form of a Bitcoin address, but it's actually just a representation of the public key, of the private key that the user has used to sign into this app. So each app gets its own unique storage bucket, and that's deterministically calculated off of the private key that's used to sign their sign-in request. So that's really nice, and that the way if you want to read and write to the user's storage, all you do is you take the private key that the user's app gave you, and then you sign something through an API, and that request gets sent along with data you want to store, and lets you store data in the hub. And besides getting this app user-specific private key, using it for storage, you can also use it for creating cryptocurrency wallets. So I wrote a blog post, I think, I gave a talk at the Ethereum Classic Developers Conference, and I showed people how to make a Ethereum wallet with Blockstack in 3 lines of code. It's pretty easy. All you do is you take the private key and display it as a Ethereum address wallet, an Ethereum address. Okay, cool. So there are a bunch of things you can do now that you have sort of like this username with an app and a place to store data. You can do some cool things with it. You can look at other kingdoms. And you can look at, these are other people's, I think some of them are offline, but you can look at one that's online. So here we have the last one, MA1222, that Lion Kingdom, that's Mary's kingdom. You can click on that and you can actually view what her persona is, and you can see what sort of territory she's in. And what's interesting about this is that you're actually making a peer-to-peer request. So what you're doing is, happening behind the scenes, is you're doing a lookup on this person's name, lookup that's running off of a Blockstack node, and you're getting a response back that says, hey, this name is owned by a certain public key. And then once you have that public key, you can do another lookup, and you can get the link to that person's storage hub, guide storage hub, and then you can read data directly off of that user So you can actually do multiplayer apps and interact with other people without having to go through a server that you control. And sort of the implications of this are like you can take the private key that you're given when you sign into an app, you can encrypt some data with it, store it on the user's hub, and then you can, another user can read that, well, they can't read that data. You could actually ask the other, let me start over again. So you can take the private key and you can store a copy of the public key for that private key on the user's hub, and then you can, in a known location, and then another version of your app that a user is running, they can look up your friend's public key and they can store some data encrypted for that person on their own hub, and that user can read that data in a way that no one in between can see. You don't have to do anything with key exchange. It's really pretty easy. So it lets you make really easy like apps where you can interact with people in an encrypted way. So there are some steps in this tutorial that you can take on your own time where you sort of customize the kingdom. What you can do is you can sort of like add, I'm not going to walk through that now because it gets a little bit involved. You can, actually, why don't I open it up and look at it? Let me open up the VS Code. How much time do we have left?
25 minutes.
25 minutes?
Yeah, we have to go like 55.
Oh, okay, cool. Oh yeah, we can take a look at that later. First of all, any questions up till now? I know I threw a lot of stuff at you. I want to make sure that the basics are understood.
I have a question.
Yes, please.
So when you say the data is stored on the user's hub, is that on the local storage, or you can also access that data when they're online? Is it save that data when they're online? What about they're offline?
So storage hubs need to be online, and they need to have a publicly accessible URL. So it's stored on a server. It's a server the user runs and run their house. They can use a public one that somebody runs on their behalf. They can run their own on a server they have at home, as long as it's publicly accessible, AWS, Google Cloud. It's a really simple piece of software that lets you repurpose existing cloud storage to be a public key cryptography accessible storage. Does that make sense? Any other questions? Okay, so let's take a look at some of the different pieces of the code. Let me load up the website for that.
So it's essentially not serverless.
When we talk about serverless, serverless has servers. I mean, the way most people use serverless is talking about AWS Lambda, which is a server, right? It's a server that runs your code. What we think about when we talk about serverless is we think about having the code, the business logic run on the client side. So it depends on what your definition of server is.
With no access from the server, that would be serverless for a long time.
I'm sorry?
With no access to the private information from the user would be serverless that you're trying to achieve.
So in my view, what serverless means, well, I think with the way the industry uses serverless, it's like basically a branded term that people need to use to mean, like you don't have a long-term app server running, and you send some code. Like you spin up a server for one request, and you turn it off, as opposed to having a long-running app process. So in that instance, it's not serverless because that's what serverless means. It's also not serverless in that there are types of servers that are involved. There's a server that's connected to the node, which gives you information about name to public key mappings. There's a storage server, but there isn't necessarily a server that's running business logic. I think that's the serverless aspect of it. So you can make apps that are built around data protocols, so like the way your data is stored in the user storage, and you don't need to run You need to have a web server that serves your single-page JavaScript app, but you don't need to have any logic running in that web server. You can have all logic running in the client side. Yeah. Does that make sense?
Perfect.
I mean, and ultimately, we're not there yet, but where I would like to take this is to make it so that, like, I'm looking at ultimately breaking the connection between, like, one of the things we have on the web is every time you click on something, it sends a request to the server. You can override that, but by default, it goes back to the server. And I'd like to get to a world where you can download like a bundle of like HTML, JavaScript images from somewhere. Maybe the app developer's web server, maybe IPFS, maybe somewhere else. And then once you have that, you can just run it essentially offline. It's online in that like it can interact with your friends. It's online that it can talk to your storage, but it's offline from the developer. Like there's no reason for the developer to get every request that you make. So I think that if we figure out how we can break that connection, then we can sort of really reduce the surface area of privacy that we're using.
Can I ask you?
Please.
So basically, this is kind of, I mean, I'm fully with you. I'm very privacy concerned. I'm always deleting my cookies when I close my browser.
Awesome.
But basically, this goes totally backwards, kind of, right? Before we had everything local, then it went to the cloud, and everything is like your thin client, and you have running things on the remote server. Now you're saying everything runs on the local client again. I guess that's also reasonable. But you say, okay, all the privacy issues are a big concern. I agree. But like all the services that are running right now from Facebook and Google are only possible because there's no privacy and they make money with our data. So what will be the future business model for distributed applications?
I mean, I think that
Testing. I think that that the future business model is that you have to pay for software again. So I think that I understand that's very difficult for people, and so I suspect that the group of people that will pay will be small in the beginning, and I think it will grow to some extent. I don't know if it will ever be like, I mean, as an investor, people would love to say, like, I think it's going to be like everybody's going to just go back to paying for it because they're going to care about this. I think that's probably the biggest problem that we face. So one way to look at it is that like a minority of people like that have money will pay for it and have privacy. Sort of look at it, the Apple-Android split. I mean, I know that Apple doesn't deliver as much privacy as they claim, but like that's what they market on. So people are willing to spend a lot of money on that. And I'm starting to hear from family members that are not technical. Oh, I'm getting an iPhone because I think it's more private. So I think you may see a split in the world where there's groups of people that have the resources to pay for things that are private, and there's those that don't. And yeah, so that may be the way things are going to go.
Digital peasants.
What's that?
Digital peasants.
Digital peasants? Well, we're all digital peasants right now. We're farming our little page on Facebook, or farming our Twitter account so that we can get more followers, so that Jack can make more money. But I think Elysium, if you've watched the movie Elysium, yeah. Anybody watched Elysium? No? It's a movie where like Earth, like there's all the rich people live in a space station above Earth, and like it's really nice, and everybody's beautiful, and like it's like beautiful green lush stuff in the space station, and Earth is just like this dry desert of like poor people. It's not a very good analogy, but maybe that's what'll happen.
that's that one.
Okay, so in the last few minutes, I'm going to walk you through some of the code. But of course, I haven't tried this yet, so it's failing. Apparently, Microsoft has not notarized their software for macOS Catalina. Okay, so if you open up the Animal Kingdom folder in your favorite code editor, I'm going to walk you through some of the different parts of it. Yeah, so this is the, you probably see the flashing. This is the problem I was having with Chrome. I think there's a problem with Chromium when you run it in a virtual machine, at least on my computer, where some of the rendering flashes like this. So if you look at the source directory, src, there's a number of different files. You can open landing.js. Come on, text. That's not really visible, but so if you look at that file landing.js, you'll see that there's two different things that are happening that are related to Blockstack. Three different things. There's the second line imports something called user session from the Blockstack library. The user session is an object that holds all of the data related to a session for a particular app, and particularly a user that's signed in. The next thing you'll see is that when the landing React component is constructed, an instance of the user session app is created. And that's that's configured by a constant called appconfig from the constants file, which we can take a look at if it displays here. I'm unfortunately unable to view this file. Anyway, there's a bunch of constants in there that tell the class about various settings of the app. And then when the user clicks the sign in button, you call this redirect to sign in function, which is right here. And that generates the authentication request token and does the redirect to the user's authenticator, which in this case is the Blockstack browser. And then what happens is when the user signs in, you come back and then call this other function called handle pending sign-in, which does a verification. And then once you've done that successfully, you can use the user session object to access things like their name, their profile picture, things like that, and then you can read and write data to their storage using functions called putFile and getFile. Fortunately, I can't show that to you because it's not rendering on my screen, my virtual machine. Okay, cool. Well, we have like a couple minutes left, so I want to get time for questions, but I also want to tell you one more thing. So I'm going to go back to this presentation. So if you make an app on Blockstack, you can apply for app mining, which is a chance to get some of the money that's available every month. So most recently, I think it was $200,000. And the way it works is every month, all the people that submit their apps to app mining, their apps get reviewed by 4 different companies, of which my company is one here on the bottom, New Internet Labs. So Product Hunt, Try My UI, Awario, New Internet Labs. Each of these companies review apps for different functions, different characteristics. Product Hunt looks at how popular the app is in the Product Hunt community and some other proprietary facts that they don't really share. Awario looks at the reach of your app and your marketing, like how many times does your app appear on various social media platforms, press that you've gotten. Try My UI has people review the usability, UI, UX of your app. And my company looks at digital rights. What we currently look at is whether or not you use Blockstack authentication and whether or not you use Blockstack storage. We're looking to sort of expand that in the future to look at more of these can't be evil properties that I just recently mentioned. But we're not currently doing that this month. And that's all I have for you today. If you have more questions, feel free to email me. If you want to join the Telegram group, there's a QR code up there. If you're interested in app mining, you can go to app.co/mining. Yeah. Thanks so much for listening. Any questions?
Question from audience? I got a question.
Please.
Please go ahead. Like, if I try to be that devil's advocate, I want to be evil. Okay, how would I go about it on WhatsApp?
So the question was, if I want to be evil, how would I do that on Blockstack? Currently what you do is you'd take the private key that you get when you sign in, and then you'd send that someplace else. So when you sign into an app, you get a private key specific to the app, but it's intended to be only used within your app on that user's device, but you could, of course, post it to Facebook or send it to wherever you want, really. So that would be an easy way to be evil, because then the user would think that their things are being encrypted, but actually the private key is floating around. So that's one of the things we're looking at building software to make sure that doesn't happen. Any other questions?
Why do you think people don't care about privacy that much?
I think that people do care about privacy, but it's usually when it has to do with their money, or Ethereum, Bitcoin or Ethereum, for good examples. So we had one of my favorite apps on Blockstack, which I can show you in the last. I can show you. It's called Mythos.io. It's a really awesome Bitcoin multi-sig wallet. It makes it really easy to make multi-sig wallets and basically a payment system for your business. You can create a joint account. You can add people, remove them, vote on adding them, and removing them.
Is that the one from the French guy?
He's German and he's in Germany. I can load it up right here. So that's really great app, and the answer, he had trouble getting, I don't know where my pointer went. I can't show it to you. So I guess I'm testing outside for him. It's not working that well. I don't know where it went. So anyway, he was trying to sell this web-based multi-sig wallet with a really great UX to some Bitcoin whales. Hey, put your Bitcoin in this wallet. And they're like, I'm not putting my Bitcoin in Google Chrome. Are you nuts? It's kind of I don't know where my private key is going. So I think that's one of the big pushbacks is that if you have any significant amounts of funds, you're going to not really want to put them into anything that has to do with a current web browser. Extensions are not super safe. That sort of thing. So I think that people do care about privacy, but when their finances are at risk, or when the people that do care about privacy, so I live in Hong Kong, and right now a lot of people care about their privacy. This is why they buy MTR tickets with cash. They cover their faces. I think it's just that people don't always care about privacy all the time because it's tiring. And you can't. You have a million other things in your life. You can't always be fighting for privacy. The thing I do is when I go to the airport in Hong Kong, I opt out of the face scanning. And the first time I did it was really hard, and it made me really angry. Yeah, I succeeded, but I just was in a bad mood for the next 30 minutes.
I saw that blog post.
Did? Yeah, well, the great thing is a lot of people saw the blog post, and it's changed now. It's really easy to opt out. You just go and say, I'd like to opt out, please, and they are very nice about it. But that required a lot of, there was no payoff for me, and it just made me angry. And so if you're always worried about privacy, it can't always be the top thing in your mind because other things are more important, your friends, your family, your money, your business. So I think it's just a challenge problem.
They still have the photo.
They never took my photo.
Oh, right.
This is private security, yeah. I'm sure they have, anyway, that's a different topic we can talk about today.
We can talk about Canadian customs.
All right, let's get a round of applause for Larry. Thank you for the pressure.